up doing one of these yesterday off your homework because I should have done one before I gave you the homework. We need to do product rule here. And within that product rule, we'll have to do our chain rule. So we have to do the derivative of the first one. So to do the derivative of the first one, that exponent comes down, inside stays the same, subtract 1 from the power, so it's a fourth, times the derivative of the inside, which is so that's the derivative of the first times the second one, plus the first one, times derivative of the second. So the 2 comes down, inside stays the same, subtract 1 from the power, so it's just a first, times derivative of the inside, which is
3x squared.
so that's the calculus piece. Everything else is algebra, just cleaning this up as much as we can. There is quite a bit we can do here. I'm not expecting anything crazy. So you could, if we wanted to multiply these, we could. So we get 5 plus 10x. Have an x plus x squared to the 4th. I have a 1 plus x cubed squared. And this term, you could multiply quite a bit. If you wanted to at least multiply those, you get a 6x squared, but you could take it through that parenthesis as well since it only had a power of 1. So I would take your answer like this, but I want you to be aware there's a lot of different ways we could simplify this. If you wanted to, if you look at both of these terms, they have some parentheses in common. What parentheses show up in both?
X plus x squared.
So you could take out an x plus x squared. To what power? The 4. What else do they both have?
Plus x cubed.
And you could take out one of those. So this is optional. I don't expect it, but I just want to show you other equivalent forms for your answer. So if I took that out, I have a 5 plus 10x. I took out all of these, and I would have a 1 plus x cubed left. In this one, we have a 6x squared. And we have one of these left. And I took out my 1 plus x cubed. So if I chose to multiply, I could FOIL the 5 plus 5x cubed plus 10x plus 10x to the 4. This one, if I distribute, I get 6x cubed plus 6x to the 4. So then, combining all my like terms, I have 16x to the 4, 11x cubed, 10x, and 5. Was that required? No. Could it be helpful? Yes. If we had to do a second derivative, the more you simplify before, the better. If I had to do the second derivative of this mess, I would be stuck doing the product rule 3 times with each term, and it would turn into a lot of work. This, I'm still doing the product rule 3 times, but I only have to do it once. So basically cut the work in half for the second derivative. So those extra simplifications can help if you have to do higher order derivatives. We are approaching the point where you guys won't be grading your own homework for a while because there are so many different equivalent answers that you can have on these. So I just want you to be aware, if you're checking your homework and looking at my study guide or my answer key, if you don't have verbatim what I do, that doesn't mean you're wrong. It means we might have just simplified to a different point on those. And certainly you could keep going here if you really felt like doing a lot of multiplying. You could go further, but. Any questions there? All right, let's try this one. What will I have to do here?
Quotient ruling.
So my big thing is the quotient rule. And within that, we'll have to do our chain rule. So quotient rule, low d high. So the derivative of the top. 3 comes down, inside stays the same, subtract 1 from your power. Minus high d low. So the derivative of the bottom. 2 comes down, inside stays the same, subtract 1 from the power, so it's now to the first times derivative of the inside. Which is what?
12x plus 5.
Over low squared. It was already squared, and I'm squaring it again. Now this one I do expect a certain amount of cleaning up. I would appreciate it if you can pull coefficients to the front of the term. Not that it's wrong, multiplication can happen in any order, it's just more standard to see your coefficients in the front. What could we multiply in the second term?
You have 2 12x plus 5.
You have 12x plus 5 or 5 plus 12x, either way. In the denominator, this becomes 4 plus 5x plus 6x squared to what power? That square is in the parentheses, so you just, yeah, to the 4th. You multiply those two, power to the power. All right, there is one more thing I would expect on this one. Does anybody see what it is?
Cancel the denominator because it shows up twice on the top.
The 4 plus 5x plus 6x squared is in every term. So we can take away one of those. That means 1 here and 3 on the bottom. So we get 3 times the 4 plus 5x plus 6x squared. You could distribute the 3 through that if you wanted. So if the same thing shows up in every term and in the denominator, you need to reduce it. have some ugly problems there. What questions do you guys have?
How is the derivative at the top where you do like the very high? How is it 3 times 1x squared squared?
This term,
No,
Oh, right up
in
here.
the-
the derivative of the top. So the top was the 1 minus x squared to the third, so you had to do the chain rule. So the exponent comes down, inside stays the same. Subtract 1 from the power. Did I leave off the derivative of the inside?
I was saying, I thought you had to like.
Yeah,
multiply it again.
I left off my negative 2x there,
I
didn't I?
was wondering that kind of, but I just figured I was wrong.
You should have said something. I left off a negative 2x. But that's an easy fix. So 3 times negative 2x, that would make this a negative 6x in front. Learning opportunity. I was showing you places where people commonly make mistakes. And Bryson passed for the day. The rest of you failed.
I was like, look at that. I was like, that doesn't seem right. I was like,
Yeah, I just left off the derivative of the inside there. A little oopsie. Alright, that was a very good question. Any other questions there? Not everybody at once. Let's try this one. All right. We have talked about the derivative of e to the x, and I told you it was still e to the x. Here I have e to the sine x. So this is a composition. You have e to a power, and there's a function within the power. So we have to do the chain rule here. So derivative of e to a power is still e to that power. But then you have to do times the derivative of the inside. The inside here is our sine x. What's the derivative of sine x? So it's e to the sine x cosine x. Really no way to simplify that. If you preferred to write cosine in front, you certainly could, but you gain nothing there. It's just both pieces. All right. Questions there? I want to take a little break from notes. And we did number 1. When you do number 2, the exponent comes down, inside stays the same. Subtract 1 from the power. Derivative of the inside, where have you seen that before?
The first question.
Yeah, that first question was the sine of 3x. So we already know from that the derivative of the inside was 3 cosine of 3x. So you do the chain rule within the chain rule there, or pull your answer from the previous one. So you should get 9 cosine of 3x sine of 3x squared. Did you guys get that?
Yeah, I just didn't, I never distributed the 3.
Oh. Yeah, since these 2 3's are not in an argument, they can be multiplied together to make a 9.
We're just rebels. We don't.
You were going for that equivalent form. You wanted a unique answer.
Exactly.
No one else would have. All right, so what do you notice about number 3?
It's the same thing you said.
Yeah, didn't we just find the sine of 3x cubed, the derivative of that? And we got 9 cosine of 3x sine of 3x squared, plus what's the derivative of 5x? 5. Okay, now, you certainly could have worked out the derivative of sine 3x cubed again. But that's why I like 1 through 4, they just kept adding one more piece. So your previous answer, we're just building on it. Number 4. We have the sine of 3x cubed plus 5x to the 5th. So, when you do your derivative, exponent comes down, inside stays the same. Subtract 1 from the power times the derivative of the inside. But what is the derivative of the inside?
Oh, is it?
The answer we got on problem 3. As far as simplifications there, you could distribute the 5 through that second parenthesis if you chose to, or you could leave it like this. So these 4 questions were really just illustrating how many times the chain rule can be used within a problem. Okay, the more complex your function gets, you might be using the chain rule over and over again within a problem, and that does happen. All right, any questions there? I want to give you guys some time to practice